Hello everyone. In this case study video, we will discuss about algebraic systems. Already we know that G is a non-empty subset and star is some binary operation. Then G comma star is called algebraic system. Under algebraic system, we have many type of applications are there. First one is groups, second one is rings, etc. First, Ilay Kaniga and Shashmita will explain about groups.
Groups. A group is a fundamental algebraic structure consisting of a set cubed in a single binary operations that satisfy four properties: closure, associativity, the existence of identity element, and the existence of inverse element. Groups appear naturally in many areas of mathematics and science due to their ability to model symmetry and structure. In cryptography, groups are used in systems like RSA and elliptic curve cryptography, where the difficulty of certain problems underpin digital security. For example, discrete algorithms. In physics, group theory is instrumental in describing symmetrical properties of physical systems, particularly in quantum mechanics and particle physics. For instance, the symmetry of molecules and the atomic orbitals is analyzed using group presentations. Rubik's Cube and similar puzzles rely heavily on a group theory to study the sequence and combinations of moves. Modeling each rotations as a group operations in computer graphics, rotation groups like SO3 helps in modeling 3D object transformations. Groups also support modular arithmetic, essentially number theory and cryptographic algorithm. The study of permutations and transformations, central to both pure and applied mathematics. In group theory, making groups indispensable in a wide range of scientific and engineering disciplines.
Uh, Next, Pratosha and Darshana will explain how rings are used in algebraic systems.
Rings. A ring is a algebraic structure composed of a set equipped with two binary operations, addition and multiplication. It generalizes the arithmetic of integers, where addition is associative and commutative, multiplication is associative, and multiplication distributes over addition. Unlike fields, rings do not require multiplicative inverses for all non-zero elements, making them more flexible and broadly applicable. It plays a crucial role in coding theory, particularly in designing error detection and error correction codes, such as used in CDs and DVDs and digital communication. For example, an essential in constructing cyclic redundancy checks and read codes. In cryptography, certain ring structures are foundational in modern algorithms. In computer algebra systems, rings enable symbolic manipulation of algebraic expressions, supporting operations on polynomial and algebraic numbers. Commutative algebra, which studies commutative rings, is a foundational tool in algebraic geometry and number theory, providing the language for defining and solving polynomial equations over different fields. Engineers also use rings in digital signal processing and control systems, where polynomial rings model system behaviors and filter designs. Overall, rings bridge the gap between pure theoretical concepts and practical communicational tools.
Next, Abhinesh Prashant will explain how algebraic systems helps in fields.
Fields. Field is an algebraic structure where a set is equipped with two operations, addition and multiplication. That safely that usual arithmetic rules. Currically, every non-zero element in a field has a multiple inverse, enabling division. Fields are central to much of modern mathematics and the fundamentals in areas like algebra, number theory, and geometry. One of the most significant applications of a field, cryptography, expresses the fluid fleets, also known as a Yarkov denoted GF. There are usually in algorithms like AES, Advanced Encryption Standard, equipped with chirography, and many post-quantum encryption schemes. The structure of a finite field provides the necessary mathematical foundation for secure and efficient computations.
In error correcting code, fields support the creation of rich Solomon code widely used in QR codes, DVD and data transmission, and cloud storage. The codes detect and correct errors introducing during the and the transmission. Fields are also used to algebraic geometry where they define the coordinate system of algebraic vertices and the linear algebra, where vector space is defined as over the field. Fields underpin mathematical resolving under the everything from a resolving polynomial equation to the constructing a geometric construction of a root and a campus.
Next, Mr. Gopi and Darun will explain how algebraic system used in vector space.
Vector space. Vector space is a algebraic structure formed by a collection of vectors, which can be added together and multiplied by scalar form a field. Vector space must satisfy a set of axioms such as associative, distributive, and the extents of additive, identity, and inverse. These structures are central in linear algebra, which underpin vast area of science and engineering. One of the most prominent application of the vector space in a machine learning and data science. Here, data is often represent a vector high dimensional space, and algorithm like principal component analyzing PCA and support vector machine SVMs operate directly within vector space framework.
In physics, especially in quantum mechanics, vector spaces, especially Hilbert spaces, represent states of quantum system where each operation such as inner product are essential for calculating probabilities and system evolutions. Computer graphics also heavily rely on vector spaces, pointers, directions, and frame transformation. Example, rotational scaling are also described using vectors and matrices. Similarly, in engineering, vector spaces are used in modeling forces, velocities, and system behaviors. In control system and signal processing, vector spaces allow the modeling and transformation of signals using techniques like Fourier transforms and filters. They are generally and mathematically structured, make them indisciplinable in both abstract theory and practical computation.
As a conclusion, algebraic systems are most powerful in rings, fields, and vector space, etc. Role in many areas in mathematics. So keep study on it. Thank you.